Okay, so recapping our mnemonics from this class. So we talked about randomness, how randomness is just a factor in our data set by the act of taking a sample. Okay, so it's just something there. We can't see it, but we need to acknowledge that it exists and the effect that it's having on our sample and the understanding we can extract in terms of insights. Okay, so we always have to be a little bit more cautious about our understanding with what an average is or correlation is. Okay, we can simulate this example and start to get an understanding of the randomness and its effect on our statistics by using Bootstrap resampling. This concept works by, if you were to have a bag full of numbers, you draw a ball with one number, you write it down, you put the ball back, and that's the with replacement part. Draw another ball and then write that number down. Okay, so you can build a list of any size this way with a different amount of samples, and you might draw some samples twice or you might miss other ones altogether. This is very important that it's with replacement because this creates statistical independence from our data set, from our original data set. And so we can start to gauge the randomness that's occurring in our data set. It's so simple, but it allows us to simulate the effect of taking samples. Okay. So then what we do is we construct this replicate from our Bootstrap resampling process with replacement. And then we repeat this over and over again. So we construct one sample, we take a min, a mean, or max, and then we do this over and over again. We repeat this many times over. And really what we're doing is we're simulating the data collection process. Okay, so we're going to create a Bootstrap sample replicate, take a mean or a summary statistic, and then repeat this process over and over again. And then we'll be collecting these means, these averages, these summary statistics, and we'll be able to visualize this then in many different ways. Okay. We can also, a really interesting effect that happens is as we start to collect these summary statistics is they will always be in the normal distribution shape. Okay, it's very weird. It's called central limit theorem, but it really is this emergence of normality. So the more samples we take, we essentially get to be more normal distribution. Okay. As we keep collecting samples and we grow our sample size or our summary statistic size, we are going to get essentially normal. They're all going to look the same, right? There's going to eventually, the more and more samples we take, the more normal it's going to look, but it emerges very quickly as we start to simulate this process. The idea behind what we want to do is, or the reason that we can use this then in hypothesis testing, and what it's meant to accomplish is we're meant to validate what we're seeing in our data. Okay. So are we seeing something that's statistically different or not, right? We're validating, oh, this is the average of men and women, they're different. But is that really true, right? So we want to validate our data set. And what we want to do is we're going to use this to, do we focus on a one-tailed test or a two-tailed test? Okay, and this is really going to be looking at the same thing, but really we're going to be focused on slightly different questions. Okay, and that'll be related to, are things different or are things greater or less than what's accepted, what's the norm of the accepted null hypothesis. Okay, and then so we get into null and alternative hypothesis, and this is really just how you ask the question. Null is going to be, it can be anything, but it's generally what was accepted before, kind of old grumpy man, he's stuck in his beliefs, he's not going to be changing or anything like that. So we need to have an alternative hypothesis that has enough statistical proof that we can, that it is different, right? Like this phoenix rising from the ashes, we have a new idea, but we need to prove that we can't just say, it's different, right? We think it's good, but we need to really understand this using hypothesis testing to understand how robust that understanding is. Okay. So the way that we simulate this in Python is just through a simple loop, right? We're going to simulate the data acquisitions, the sampling process, and we're going to essentially allow us to visualize in the end our hypothesis test, which will give us a better understanding of, okay, so we got a 0.6, 0.06 p-value. what does that really mean? How are my distributions really overlapping and how are they touching? Okay. So we use many mnemonics today in this class. I tried to connect things with colors, made the images unique, kind of painted little stories around them. We used color and word associations as well to help, give you another path back to each memory, each little tidbit of knowledge. Talked a lot about locations in 3D spaces when I was talking about the pictures. Um, a good thing, there's lots of writing in this class that I didn't cover, so it'd be really good to go back and just reread everything, reread the notes underneath the videos, kind of another way to explain what we talked about in the videos. Okay, so this repeating and this recalling the knowledge and hearing it from different angles and stuff, from the videos, me talking, stuff in the presentations and the stuff below the presentations, the wording and little paragraphs below. It will help just lock this stuff in your memory, and hopefully you won't need to come back to these again and again. Okay, thank you so much for joining me, and I'll see you for the Python workbook.